Hello, my name is Kay Robbins. I'm a member of the HED working group. Now that Scott has gone through some of the concepts of event annotation and HED, I'm going to do a walkthrough of annotation with HED and BIDS. BIDS stands for Brain Imaging Data Structure. I'll go through why we need annotation, some basic HED syntax. I'll give you a quick recipe for annotating. I want to also discuss expanded event files and columns and how to get annotations into BIDS. And then we'll demo some online tools that make doing all of this a lot easier. I want to emphasize that we're completely open source and welcome community input and participation. All the tools and examples are available online. So let's get started. To understand the scope of the problem, you have to know what data sets look like. So here are 4 data sets that we recently processed for OpenNeuro. The first one is a simulated driving experiment with auditory cueing. Each event file has got about 3,000 events, and the events are encoded in the value column. This is a study that was done through an ARL umbrella project, and there were 10 studies that were done in this project, and the originators decided to use an event encoding that would encompass all the different studies. So they adopted a 4-digit encoding scheme, and each column meant something else for events. The next example is the Sternberg working memory, which is a data set from Scott's lab. The files have about 350 events, again, identified by the value column. The values in that column are more intuitive than the 4-digit codes, but there's still some issues, which as we go through the examples, we'll see. This study was chosen by the many labs EEG replication study for replication. The next study, also from UCSD, is an auditory visual attention shift. The event files have about 6,000 events in them, and they're encoded by a combination of the event code and condition code. The difficulty with the encoding here is that the event codes meant something different depending on the condition code, and sometimes they meant the opposite. And so this is confusing for users and makes it very error prone for analysis. The last example is a baseline RSVP. This was also part of the BCIT umbrella project. The files have about 20,000 events, again, identified by value, but the details varied. So there are all kinds of columns with different information specifying the details of each individual presentation. The event encoding didn't quite fit into the BCIT original encoding, so they adapted a 5-digit encoding scheme for that. So the point of these data sets, looking at these data sets, is that typically event coding is very different across data sets, non-intuitive, and there are a lot of events in the files. So if you're going to annotate, you don't want to have to annotate individual events. You want to be able to annotate at a higher level. So we're going to discuss an approach that solves both of these issues. It allows intuitive annotation with a common language, and you don't have to annotate every single event. So here's the strategy. Let's start with an events file. And the idea is that we, instead of trying to annotate individual events, we create a unique dictionary of values. So instead of annotating every event code, we just annotate the unique ones and created the dictionary, which we then fill in the annotations, in this case with HED. This fits very naturally into the BIDS framework using JSON sidecars. So once you do this annotation, you're done because the values in the dictionary are naturally associated with the values in the columns through the BIDS mechanism of sidecars. For analysis, the idea is that analysis tools take the information in the events files and combine it with the sidecar dictionaries. And they take each event, which is represented by a row in the events file, and concatenate the relevant annotations from the dictionary to produce a fully annotated event. The result might be filtered on the basis of other head tags and giving an event file with the appropriate annotations in it. So this is the strategy. The annotation part is filling in the dictionary, and then downstream tools allow full mapping of the events. It avoids using the laboratory specific event codes and also of annotating each event separately. So let's look at a basic head vocabulary. Head annotations are separated, comma-separated lists of head tags, so sensory event, visual presentation, and cue are examples. Head tags come from specific vocabulary, which is organized into a tree structure called a head schema, and we see it on the left. You can reference each head tag by its path in the schema or by an individual node name. So you can say sensory event, or you can say event sensory event. Now for annotation, we almost always use the short form. Each term stands on its own, so it makes sense as an individual annotation. But the hierarchical structure is important both for finding terms within the hierarchy, but also because each node is a subclass of its parents. So sensory event is an event. And this means that searches for event will also return sensory event. So the head schema organization allows better organization of the individual terms, but also search generalization. One other comment, event, agent, and item are noun-like things, whereas action is verb-like, and property and relation are more descriptive. Using parentheses with tags from these different groups can enable more sophisticated annotation that looks more like sentences, where we have noun, verb, and direct object. So now I'd like to give a simple recipe for simple annotation. And we start with our dictionary. And the basic process we use is we determine what kind of event we have, select that tag, and then use the supporting tags. And we have a fairly extensive table of how you might go about doing that. So non-WM was a dash on the screen to indicate that the trial was going to begin. It's a sensory event. And then once we select the event type as sensory event, looking up in the table, we want to say what sense was used. Well, it was a visual presentation. We want to say what the task role was. Well, it was instructional, and it's a cue. And then we might want to fill in what was actually shown, in this case, a dash that was black, and grouping it with the parentheses makes it clear that it was a black dash and black didn't apply to something else. Similarly, the correct event is also a sensory event, but it's an auditory presentation, and its role is a feedback and a beep. This table is available in the documentation, and it gives a quick start to doing basic annotation that really does inform users of what the events represent. There's more sophisticated annotation that can be done, but this gives a really good starting basis. So finally, I'd like to talk a little bit about the structure of the event files itself. Here's on the left is a picture of a sample of the events file for the Sternberg working memory that we actually distributed. And we've expanded and replaced the value column with a combination of an event type column and a task role column. And this is important because we need every identifying annotation for an event to stand alone. And in particular, the one representing the right click might mean I saw it in the letters to be remembered, or it might mean, okay, I'm ready now that I'm done with the feedback. And so we've replaced these values with a combination of event type and task role. But because we're using head tags, these are not taken in isolation when the annotation is assembled. Rather, all of the values are looked up with head tags and concatenated to make a single annotation. So the right click is never used on its own as an annotation. It will always appear with its partner in the task role. Columns that have an NA do not have head tags put in for that event. A couple other comments here. This particular experiment had an experimental condition, which was that the number of letters to remember in each trial varied across trials. And that wasn't visible at all in the original encoding, but we computed it and added a column to make it clear what the variability was, the experimental of experimental conditions. We also added a trial column, and that can be very helpful for trial-based experiments because you never know whether the structure of a given trial is complete. So for example, in the Sternberg, there were cases where the the participant jumped the gun and indicated ready immediately, not waiting for the feedback. And sometimes the feedback occurred after, and sometimes it didn't occur at all, depending on the exact timing. So by making sure that you have good trial numbers, you prevent users from having to really worry about these trials that had anomalies in them. They're much easier to use in standardized analysis. So the bottom line here, the takeaway is that a well-structured event file is just as important as the annotations for downstream analysis. And now we're going to do some demos.